Hey everyone, welcome back to the Teardown channel. This would be take 3, I believe. Oh, my camera keeps shutting off, and I don't completely understand why. Uh, this time, I'm gonna keep my eyes on it, and I'm gonna see if this guy shuts off. That's extremely frustrating because I had a very successful teardown of a Polk audio, soundbar, and wireless subwoofer. Now, the reason that this is very interesting is because back in 2010, when this unit was manufactured, having a low latency wireless signal for the subwoofer, and it also had capacitive touch controls on the soundbar, both of those were newfangled ideas. It was only like 5 or 6 years ago that capacitive touch on appliances really became prominent, and low latency wireless really wasn't a thing back then. So, let's take a look again. I think I've rehearsed this quite well now. We can take a quick look every single time I go through this. I think the look is getting quicker and quicker, right? So let's take yet another look at the wireless. Let's start with the wireless subwoofer. Let's go ahead and take a look. Okay, so inside my wireless subwoofer right here, notice that my kids accidentally put their foot through the base as they're standing on it. They rolled it over and damaged the cone. So that subwoofer is trash, and it's going to buzz from here on out, so I'm not going to do it. I'm just going to tear it apart for you and for me. The subwoofer is a 6 ohm 40 watt subwoofer. It looks like it's what, 6 inch diameter, 7 or 8 inch, I don't know. It doesn't really matter. It does have a tuned port inside. So the port looks like a J. So down here in the back, it goes in and it curves to the open chamber. There's lots of dampening foam on the inside because it's a thin plastic case, and a thin plastic case tends to resonate and vibrate, and it might not be the desired resonance, correct? Because it's plastic. You get that plasticky sound to your audio. So inside the wireless subwoofer was a chamber, like so, and in that chamber was, well, let's start from the base plate. So the base plate had a bow tie style power port. This guy right here, I clipped it out because I salvage components like that. And we had a dual pole, single throw power switch right here. Pretty good. I'm going to salvage that guy as well. And inside was this amplifier board and a switch mode power supply. This guy right here. Now the switch mode power supply, it says over here that it's 5.5 volts. I honestly believe it's probably 12 volts because it would be very difficult to get 40 watts at 5.5 volts. I don't know, because that's pulling, a reasonable amount of amps. It would just make more sense to rectify the voltage and limit it at 12 volts. But I think this might be a dual voltage output. I don't know, hard to say. But this guy is going to be perfectly fine. You have your AC power comes in, it gets filtered, goes through switching, and then it gets rectified, and then it gets smoothened, and your output is going to be your 5.5 and or 12 volts. Guess I'll figure that out in another video, but that's a switch mode power supply. Now normally, you would not have a switch mode power supply and an amplifier next to each other in close proximity. The reason you wouldn't have those close to each other is because switch mode power supplies are electrically noisy, and if you're amplifying a signal, any signal, and there's electrical noise that comes in, you're going to amplify that as well. So, in this application, I don't think it's going to be that big of a problem because you have a low pass filter over here on your audio processor. Now this is the reason why there's a low latency between the transmitter and the receiver. This is the receiving chip, and it looks almost identical to the chip that's found on the amplifier board that was inside the soundbar. We'll take a look at that, but it seems to be a custom solution, matched pair, and those custom configurations are why they can have really low latency. So the power comes in on this board, it gets regulated and filtered, whereas it comes over here, and this is going to be the received signal The received signal comes over to more filtering, and then it comes into your amplifier, comes in on one side, goes out the other side, through a low pass filter, and out to your subwoofer. The low pass filter is the reason why it can be in close proximity to a switch mode power supply. Switch mode power supplies are normally high frequency, noisy. This is a low pass filter, and it kicks out and limits all those high frequency noises, and only the low frequencies come through. That is why they can be close to each other. I really dig this heatsink configuration. It bolts through the board, and it sinks down tightly. Now, eventually, this was probably going to fail if I drove it really hard, just like any audio equipment, and just like switch mode power supplies. I did a whole video on the Better Biomed YouTube channel where I show how to improve the life expectancy of any semiconductors, especially the ones that use heat sinks. You can see right there the thermal compound, how it's kind of smeared off to the sides. Well, on this particular one, yeah, it's like powder. It's extremely dry. And over here as well, on the amplifier chip, it's very dry. And when it's that dry, it doesn't conduct heat as well from one component to the heatsink. And in doing so, eventually that component is going to overheat, and it's going to fail, usually in a short, or it's going to be limited. It's going to thermally limit itself. Either way, if you want to extend the life of your components, you have to open it up, change out that thermal compound. Now, modern day, we have carbon composites and stuff. We have carbon fiber and a whole bunch of these different matrix semi-solid thermal compounds where they conduct heat in one direction very well, but in the other direction not so well. And those would be a long-term solution for modern day electronics, because you can place that compound between the heatsink and the semiconductor, and because it's a lattice matrix and it's not a gel, it's never going to dry out. So that's something that we're starting to find on modern day electronics. These older ones, if you don't go in and change out that thermal compound, you're eventually going to have some sort of failure. And that includes your switch mode power supplies like this guy here. Now, inside the soundbar itself, let's start from the back. It was a plastic case, and although it looks like you can pull the screws out of the board in the back, like many items, like even the subwoofer, this one here, however, you had to pull the speaker apart from the front in order to pull the retention screws to pull the amplifying board out. Now, on most units, you pull the screws on the back and the amplifying board slides out the back. It's not how they chose to do it. Maybe for good reason. Now, one of the things I can tell you is attention to detail. They use a lot of sound deadening material like they did here. They have some tune ports, oddly enough, right here. And around the perimeter, you'll see on the front fascia is where they have foam. So they want to limit as much vibration as possible. So there's excessive screws, good on them for that, but there's also a lot of foam. And notice here, they have Celastic and they have hot glue. On the front board, it has 4 of these mid-range, I don't want to call them tweeters, but they are mid-range speakers. We have capacitive controls right here that I mentioned earlier. This was a rarity back in the day to have capacitive controls, which is one of the things I really digged about this unit, something new. You can see my infrared sensor right here. Now, the interesting thing that I found out when I opened this device up is that normally you would think the left channels are matched over here, the right channels are over here. But what this vendor did is they have this speaker and this speaker over here on the same board, and then this one and this one on the same board. Okay, I'll show you. It's really interesting. So over here you can see we have a crossover board. We have an 80 microfarad 50 volt cap and a 2.5 millihenry and a 0.5 millihenry inductor, and this is going to be my crossover. So all the audio frequencies come out of the amplifier. As far as I know, it's all audio frequencies. And then the crossover board, its number one job is to both balance out the circuit and the load on the amplifier, but at the same time, it's going to only limit the frequencies that are desirable for these speakers. As I said, you would think this speaker and this speaker are plugged into this board, those speakers are plugged in, but notice they got these runners, and there was another runner for this speaker over here. So this speaker and this one, way over here in the side, those are running off of one crossover board. And likewise, this one and this one. I would think that that would absolutely eliminate whatever stereo sound is coming out of this, but what do I know? Maybe it's not. Maybe it's better, right? Okay. Anyway, this is the back of the touch control, and this right here is the IR receiver, the sensor, just a little daughter board. I have no idea what these speakers are rated at because I don't see any print, and the only way to probably get to it is to pull this foam off. I'm assuming they're 4 or 6 ohms, might even be 8 ohms since they're so small. Who knows? They look like they're in a reasonably good condition, so maybe I'll save those for a future project. I guess one other thing I'll bring up. I said earlier about the foam. You can see the foam here, and notice the foam on the back of each of the speakers. And they put foam right here, along with some hot glue. They really are trying to limit the rattles. So everything that could rattle, like the runner wires, the back of the speakers to the front, and the case itself, everything that could rattle has got foam on it. Interesting. They actually had some attention to detail. Inside that guy right there. Now this has a DC input. I have a PCM input, and that's optical audio. And I have 2 3.5 millimeter stereo, and I've got a power switch and a little status LED. So that means that there is no active power switching inside this guy, which is, it's good. For one thing, it makes the form factor smaller. And for two, as I said earlier, those high frequencies, you want to get those as far away from your mainline amplifier as possible, because those high frequencies will carry over and you will hear that noise in your audio signal. So this little interconnect board right here is sat over this. You can see that they shielded it, and there was a redundant ground that kind of came over from your DC power jack. And what they're trying to do is create a little Faraday cage, because these 3.5 millimeters, when the audio comes in, it's a really weak signal, and they have to amplify that correctly and isolate it so that we're not amplifying bad signal. So you can see they have a little Faraday cage made of copper that sits over top of those. And over here is your main signal processing. It's a Cirrus Logic chip. And here we have kind of a breakout board. You can see we have some filtering that's going on, and these are your audio outputs. Again, those are your audio outputs for the soundbar, which means these are going to be hopefully all your higher frequencies. The lower frequencies on this unit are going to go this way through the board, and this is your power switch on the unit. So even though it looks like that's the DC power in, it's a power switch. We do have some voltage regulation, power switching, and I believe we have a fuse over there. But over here is where the magic is. We have some low pass, and over here is that matched pair RF TX. That's the transmitter. So that matches up with this guy over here. And these two boards talk. Now it looks like the antenna is integrated into the chip. I was expecting to see some sort of antenna maybe down the side of the board. I don't see it. Looks like it's all embedded in the chip. So this guy sends the low filter signal. I assume it's low filter. Maybe it's full bandwidth, and you're relying on your low pass to filter out just the low signals. I don't know. But I would assume that they would isolate the low signals, send them over to this guy where it gets filtered out with your low pass. Anyway, this is the board that sits inside there. So we got 4 mid-range speakers, 1 subwoofer. We have a low latency RF signal, which is controlling your subwoofer, so you can place it anywhere in the room. Revolutionary technology. And we had the capacitive touch interface, something I've never seen before. It was right around this time, about 10 years ago, we really started seeing it. Some very cool tech. But anyway, guys, even though this was my third take talking about this stuff, I'm still going to get the video out of it because I still think it's some really cool technology. There is some takeaways from this. One is the power input ports and the switches. I'm going to save those. Those are still good. Can always use switches. Things break where the user interfaces with the device. It's always going to be your switches. It's always going to be places where things plug in. The DC power jack, I'm definitely saving that. The PCM, not so much. We don't even really use PCM anymore. 3.5 millimeter ports, yes, they break those all the time. And the low power switch here, I think I have enough of those. But nonetheless, this will probably go in my electronics bucket. I do have some really good inductors over here on the low pass, or on the power. This would be the audio filter for the high pass. The capacitors, not so much. I think I have a whole kit of those, but those inductors, I have seen those get smashed off of boards before, so I'll probably save that. Hard to say. There are some very few components I'll save. I really dig this heatsink that was machined so it can screw down. This board over here, I don't know what I'll save off of it. This connector right here is probably going to be a good takeaway off of it. Everything else is kind of celastic, glued down. Not really worth it. And the switch mode power supply, that one I'll probably almost certainly keep. I might use it for a project or something. If it's 5.5 volts, it's putting out considerable amps. If it's 12 volts, still putting out reasonable amps for a project, maybe even for an educational project for kids or something. Who knows? We'll do it. Anyway, guys, that is my Polk Audio wireless subwoofer soundbar system from 2010. There you go. All right, guys, thanks for watching, and stay tuned for more videos. I got some cool stuff I'm going to be tearing apart. And next time, hopefully I can do it in one take so that y'all can see me pull out the 100 screws. Thanks for watching, guys.